Hi, welcome to Dr. Abu's channel. Today we are going to discuss one CBSE 2025 question paper. Okay, code number 5571, question number 31. An electric dipole of dipole moment P consists of point charges plus Q and minus Q separated by a distance 2a. Derive an expression for electric potential in terms of its dipole moment at a point at a distance x much greater than a from its center and lying along its axis and along its bisector line. Okay, to start with the numerical, we should recall one theory related to this one, that is about the electric dipole. I think you heard in the class, right? Electric dipole. Basically, what is electric dipole is? It is a combination of two equal and unlike charges separated by a small distance. So we can say like this one, electric dipole is a pair of equal and opposite charges separated by a very small distance. And we can draw this one here. Just wait. So two charges, right? So one is minus Q separated by a distance 2a we can write, or 2l we can write, plus Q. Separation between them is 2l. Okay. Now we are going to write the electric potential. So what is electric potential is, you heard, right? Usually we tell like just potential, that means electric potential. So electric potential at a point P at a distance, we can write R, okay, at a distance R from the charge Q, we can write like this one, okay. At a charge Q, the letter used to represent the electric potential is V, capital letter V we are using. So that we can write, before that we can have a small drawing, plus Q, charge here, point P is at a distance R from the charge plus Q. Now we can write the potential V is equal to 1 by 4 pi epsilon 0 Q divided by R. This is the equation for potential. Now we can come to the question now. See, the question was something like this one. There are two equal and unlike charges, right? Plus Q minus Q. And we want to find the electric field along its axis and perpendicular to axis. Perpendicular to its axis we will tell like a bisector axis. So first part, along the axis. So we can draw one electric dipole now, because two equal and unlike charge basically representing one electric dipole. So minus Q here and plus Q here, separated by a distance 2a. So this 2a, by considering the center of the dipole, we are marking like a and a. And the point P is along its axis at a distance x from the center of the dipole. Image is clear, right? The drawing is clear, right? Now we need, when we go with the electric potential calculation, we need the distance of the point P from the charge plus Q as well as from the charge minus Q. From the charge plus Q we can write x minus a. If you analyze the diagram you will come to know that one. And the distance from the minus Q you can write till center plus one more a, so x plus a. Now we start writing the equation. Electric potential at P due to the first charge we can consider like a plus Q is V plus Q is equal to, or V plus we can write, or V1 you can write, that is up to you. V plus Q is equal to 1 by 4 pi epsilon 0. The equation was charge divided by distance between them. So here the charge is plus Q and the distance between them here for plus Q is x minus a. That is our equation number 1. Okay. Now we come to the second part, that is the electric field at the point P due to the minus Q charge. And our final plan is then the total potential at the point P will be the sum of these individual potential. Okay. So electric potential at P due to minus Q is V minus Q is equal to 1 by 4 pi epsilon 0 minus Q divided by, that is because here the charge is minus Q divided by x plus a, because the distance from minus Q to P is x plus a. Now we can write the total potential. The total potential will be the sum of these two. So the total electric potential at P is, we can write like V is equal to potential due to plus Q charge plus potential due to minus Q charge. That is basically equation number 1 and 2, the addition of these two. So we can add them now. So 1 by 4 pi epsilon 0 due to plus Q is plus Q divided by x minus a, plus 1 by 4 pi epsilon 0 minus Q divided by x plus a. Yeah. Now we will go ahead. We will take the common outside first. So 1 by 4 pi epsilon 0. Okay, 1 by 4 pi epsilon 0. Q also outside because Q is common in both the time. Inside bracket 1 by x minus a. Then actually there is a plus. But the second term having a minus Q. So the overall result will be in the middle, minus will come. Minus 1 by x plus a. Now we work on this like normal LCM work, okay. So Q by 4 pi epsilon 0 inside the bracket. You know the method, right? Cross multiplying 1 into this numerator into that denominator, that is x plus a, minus that numerator into the first denominator, divided by denominator will be multiplied each other, s minus a into x plus a. Now open the bracket and write v is equal to q divided by 4 pi epsilon 0 inside the bracket 1 into, we can write as it is, x plus a, but without bracket now, okay. Now when opening the bracket, we will see that minus 1 into minus a, that will become plus a. So minus x plus a. Denominator is in the format of a minus b into a plus b format. So a square minus b square, right? So x square minus a square will come. Now v is equal to, also numerator we can cancel that x because plus x is there, minus x is there. So q divided by 4 pi epsilon 0, 2a divided by x square minus a square. This is the standard derivation for field potential along the axis. And as per our question, you remember, for a point which is far away, that is much greater than a was mentioned there. So we'll come to that one after this one. Before that one, here q into 2a, one term is forming in the numerator. That is actually the term electric dipole moment. Okay, we did not discuss that one in the beginning. Along with the electric dipole, we can discuss that also. Q into 2a is equal to electric dipole moment. So P is the letter, P is used to represent that one. So the electric potential at a point P along the axis is V is equal to 1 by 4 pi epsilon 0 P divided by x square minus a square, we can write. Okay. Just finish this one. So the term name is electric dipole. The letter used to represent that one is P. And we can come to that special case. What is the special case here is when the point is far away. So in the question it is given in this format like x much greater than a. So x square minus a square approximately equal to, we can neglect the term 2. So that square term, which is a small value as well as a square term. So it will be more smaller. So we can take almost equal to x square. So v is equal to 1 by 4 pi epsilon 0 p divided by x square. Okay, x square. It is gone out of the screen, but x square. Okay, a square will be disappeared. First part done. Now we come to the second part. The second part is electric potential along the bisector line. What is bisector line? Is a line which is passing in the middle of these two charges. Okay, middle of these two charges and perpendicular line. Okay, so let me draw one dipole first. Minus q separated by a plus a, right? 2a plus q, distance between them is plus q minus q. And the point P this time is at a distance x from the center of the dipole. Okay, point P is at a distance x from the center of the dipole. Distance between charges a and a, that is 2a. Clear? Yeah. Then the distance of the point P from the center of the dipole is x. Now using Pythagoras theorem, you can write this hypotenuse. That will be square root of a square plus a square, or a square plus a square, you can write. Pythagoras theorem, everybody know, right? That applied here directly. Similarly, we can write left side also because it looks like an isosceles triangle. So a square plus a square. Now the work is easy, the same as before. Potential due to plus q charge we will write at the point P. After that we will write potential at P due to minus q charge. The same method we will follow. So the part 1, the electric potential at P due to plus q is, okay, plus q is V plus q is equal to 1 by 4 pi epsilon 0. You remember the method, right? The charge, that is here it is plus q divided by distance between them. Remember, for potential there is no square term, okay, but electric field there is a square term. So here's distance between the point charge and the point is square root of x square plus a square. Same thing we will write. So what we wrote is the electric potential at P due to plus q written, right?